Bavaria is a state in Germany. October 1944, Chief Engineer Franz Hartmann stood in the cold hangar at the Rechlon Test Center, looking at the airplane in front of him with both interest and anxiety. The North American P-51 Mustang was shot down 3 days earlier, and its American pilot is now a prisoner. The fighter was mostly unharmed, and that made it very valuable for gathering information. For months, Luftwaffe pilots had been yelling into their radios about a silver enemy plane that followed American bombers all the way to Berlin and back. Unreachable distance, incredible speed, and unbeatable movement. Now Hartmann would finally understand what made it so dangerous. As he got closer to the Mustang with his tools and notebooks, he had no idea he was about to find something much more frightening than just another enemy plane. He was about to find out something that would make him understand that the war was already over, not on the war fronts, but in the factories of two allied countries working together as a powerful industrial team. Franz Hartmann was not a fighter. He was a 38-year-old airplane engine designer who had worked his whole career at Daimler-Benz. Before the war, he worked with British and American co-workers at international aviation meetings, talking about engine power, how engines compress air, and designs for superchargers. He believed in numbers, math, and the clear reasoning of engineering. He found politics boring. He found ideas and beliefs annoying. He only cared about what was effective and what wasn't. His work at Rechlon was easy. Look at the captured Allied planes. Find out what they're good at and what their problems are, and give advice to the Luftwaffe on how to use this information. He looked at many enemy planes like Spitfires, Hurricanes, P-47 Thunderbolts, and B-7 bombers. Each test had been eye-opening and sometimes unsettling, but nothing could have gotten him ready for what he was about to discover in this Mustang. The P-51 was known to be very powerful and scary. It showed up over Germany in late 1943 and changed everything. Before the Mustang, American bombers flew deep into German territory without protection, and German fighters easily shot them down. The Mustang could travel from England to Berlin and back, covering over 1,000 miles while fighting enemies the whole time. It was quicker than the Bf-19, more maneuverable than the FW-190, and it just kept coming. German pilots called it Der Henker, which means the executioner. Hartmann read the intelligence reports with a careful and doubtful attitude. Nervous pilots made every enemy plane seem worse than it was, but the actual numbers were clear. The Luftwaffe had lost 3 times as many planes since the Mustang showed up. Skilled pilots were dropping from the sky. The Americans made something that Germany really needed, a long-range fighter plane that could control the skies. Now he would find out how they did it. Hartmann walked slowly around the Mustang, holding a notebook. It was lovely, he had to agree, stylish and efficient, with smooth shapes that showed it was designed to move easily through the air. The aluminum surface was smooth, the rivets were placed perfectly, and there were no signs of cutting corners or using different materials. This was a well-made airplane. He climbed on the wing and looked inside the cockpit. The equipment was complete, but not too complicated. The radio equipment was new and up-to-date. The canopy gave excellent visibility, helping a lot in aerial combat. Everything he saw showed him what he already understood. This was an amazing fighter plane. But the engine would reveal the true story. Hartmann and his 2 helpers started taking off the engine cover. It was a careful process, piece by piece. While they worked, he thought about different options in his head. The Mustang performance showed that its engine likely has at least 1,500 horsepower, maybe even more. This meant using either a big round engine like the American R2800 or a liquid-cooled straight engine like Germany's DB605. Because the Mustang is thin in shape, it needed to use a straight engine. The cover came off, and Hartmann saw the engine. He felt confused at first. The setup looked really familiar right away. A V12 engine that uses liquid to keep it cool and has a special place for a supercharger. He had seen the same design before. It looked very similar to the Rolls-Royce Merlin, the engine used in the British Spitfire. But that didn't make sense. Why would an American fighter use a British engine? He got closer to look at the marks and stamps on it. His helper stood next to him, just as confused. Klein pointed to the part of the engine. "Hey, Oberingenieur, check this out." Then Hartmann saw it clearly marked on the engine block. Packard Motor Car Company, Detroit, Michigan, USA. For a while, Hartmann just looked at those words. He found it hard to understand what he was looking at. This was a Rolls-Royce Merlin engine, one of the best airplane engines ever made by British engineers. But it was made in America by a car company from across the ocean. The impact of the situation struck him hard. He took out his reference books and started checking them. The Rolls-Royce Merlin was an amazing engine that made more than 1,500 horsepower and was very dependable. It drove the Spitfire, the Hurricane, and the Lancaster bomber. It was Britain's most valuable military asset, and somehow the British had given this technology to the Americans, who were now mass-producing it. The level of trust and cooperation this represented was staggering. Hartmann knew that Germany hoarded its technology jealously. The idea of sharing advanced engine designs with Italy or Japan was unthinkable. Each Axis power worked in isolation, protecting its secrets. But the Allies had done the opposite. They had taken Britain's best engine and handed it to America's industrial might. It was strategic thinking on a scale Germany couldn't comprehend. His assistants began a detailed examination of the engine while Hartmann took notes. What they found was extraordinary. The Packard-built Merlin was not just a copy. It was an improvement. American manufacturing techniques had refined the British design. The tolerances were tighter, the materials more consistent, the quality control superior. Components were interchangeable between engines. Klein, who had worked on Daimler-Benz engines for 15 years, made an observation that chilled Hartmann to his core. Her Oberingenieur, look at the manufacturing quality. Every cylinder is perfectly matched. This engine was built with unlimited access to high-grade aluminum, steel alloys, and precision tooling. They're not struggling to make these. They're making them easily. Hartmann requested intelligence files on Packard and the Merlin engine production. What he learned made him feel physically ill. Packard Motor Car Company, a luxury automobile manufacturer in Detroit, had been licensed by Rolls-Royce in 1940 to produce the Merlin engine. They had converted their automobile factories into aircraft engine plants. By 1944, Packard was producing over 2,000 Merlin engines per month with plans to increase to 3,000. He did the mathematics in his notebook. 2,000 engines per month meant 24,000 per year from a single company. Total Packard production would exceed 55,000 Merlin engines by war's end. For comparison, Daimler-Benz, Germany's premier aircraft engine manufacturer, was struggling to produce 2,000 engines per month total across all engine types. And German production was constantly disrupted by Allied bombing raids. But it got worse. The Merlin wasn't just used in the P-51 Mustang. It powered multiple Allied aircraft, the British Spitfire, Hurricane, Lancaster bomber, and Mosquito. One engine design produced in 3 countries, powering dozens of aircraft types. It was standardization and cooperation on an industrial scale Germany couldn't match. Hartmann examined the engine construction in detail. The supercharger was a 2-stage, 2-speed unit that maintained power at high altitude. He found documentation showing maintenance schedules. Merlin engines were expected to run for 200 hours between major overhauls, sometimes more. German engines were increasingly failing after 100 hours, or less as quality materials became scarce. The Americans were building engines that lasted twice as long, and they were building them in numbers Germany couldn't imagine. It was an industrial avalanche. As Hartmann compiled his findings, he began to understand what he was really looking at. This wasn't just about one engine or one aircraft. It was about a strategic partnership between 2 industrial superpowers that had merged their capabilities. Britain provided the engineering excellence. America provided the manufacturing capacity. Together, they had created something Germany couldn't counter. The decision to license the Merlin to Packard had been made in 1940, when Britain stood alone against Germany. The British government, despite their traditional secrecy, had recognized that survival required American industrial help. They had handed over complete technical specifications, blueprints, metallurgical formulas, everything. It was an act of strategic trust that Germany would never have made. Packard had then done something remarkable. They had converted the British measurements from imperial to metric, redesigned components for American mass production techniques, and improved the manufacturing process. They had taken a hand-built British engine and turned it into a mass-produced American product without losing quality. In fact, they had improved it. Hartmann thought about Germany's relationship with its Axis partners. Each nation fought its own separate war with its own isolated industry. The Allies had created a unified industrial war machine spanning 2 continents and multiple oceans. The implications for the Mustang's performance were clear. The Packard Merlin gave the P-51 the power and altitude performance it needed. Combined with the Mustang's exceptional airframe design and large fuel capacity, it created a fighter with over 1,000 miles of combat radius. No German fighter could match that. Hartmann requested additional intelligence data on P-51 production. The numbers were soul-crushing. North American Aviation was producing P-51 Mustangs at a rate of over 500 aircraft per month by late 1944. Total P-51 production would exceed 15,000 aircraft. Combined with the thousands of Spitfires and other Merlin-powered aircraft, the Allies were deploying tens of thousands of fighters powered by the single-engine design. Germany's entire single-engine fighter production for 1944 would be approximately 25,000 aircraft total across all types. But German production was constantly disrupted. Allied bombing raids destroyed factories faster than they could be rebuilt. Material shortages forced compromises in quality. The Packard Merlin production, by contrast, was untouched by war. The factories in Detroit operated 24 hours a day, 3 shifts, 7 days a week. Raw materials flowed in unlimited quantities. Skilled workers, including thousands of women, operated precision machinery. Hartmann calculated the engine production ratios. By 1944, Packard alone was producing more Merlin engines than Germany produced total aircraft engines across all manufacturers. The Allies were winning an industrial war through partnership. Germany was losing it through pride. The result was undeniable. Germany, with its ideology of racial superiority and distrust of allies, had chosen isolation. The Allies, through trust and cooperation, were burying them in aircraft. Hartmann's final report was 47 pages long. It documented the Packard Merlin's technical specifications, manufacturing quality, and strategic implications. His conclusion was devastating. The P-51 Mustang, powered by the American-built Packard Merlin engine, represents a synthesis of British engineering excellence and American industrial capacity. The strategic implications are profound. The Allies have created an integrated industrial war machine that Germany cannot match. The report was sent to Luftwaffe headquarters in Berlin. Hartmann waited for a response. Days passed, then weeks. Finally, he received a brief message from a staff officer. Report received and filed. Recommendations noted. Continue current assessment procedures. That was all. Through informal channels, Hartmann heard the real response. His report had been read by several senior officers who had reacted with anger rather than concern. One general had reportedly said, "This engineer has been demoralized by examining enemy equipment. Our jet fighters will sweep them from the skies." The assessment was filed away and forgotten. Hartmann wasn't surprised. He had seen this pattern before. Intelligence that contradicted Nazi ideology was rejected regardless of accuracy. The leadership didn't want analysis. They wanted validation of what they already believed. When reality contradicted the fantasy of German superiority, reality was dismissed as defeatist propaganda. Silence was safer than honesty. In the months following his report, Hartmann watched his predictions come true with painful precision. P-51 Mustangs appeared over Germany in increasing numbers. German fighter losses mounted catastrophically. Experienced pilots, the irreplaceable aces, were shot down and not replaced. Replacement pilots arrived with minimal training and died within weeks. The Luftwaffe's tactical adjustments came too late. The industrial advantage was too great. For every German jet produced, America built 100 Mustangs. The statistics became overwhelming. Total Packard Merlin production exceeded 55,000 engines. Total P-51 Mustang production exceeded 15,000 aircraft. The combined Anglo-American production total was over 430,000 military aircraft. German production for the same period was approximately 94,000 combat aircraft. The Allies had produced more than 4 times as many planes. After the war, Hartmann was interrogated by American technical intelligence officers. They asked him directly, "Did you really conclude from examining one engine that Germany would lose the war?" Hartmann answered, "I concluded that Germany could not win an industrial war against an Anglo-American partnership." The Packard Merlin was evidence of strategic cooperation on a scale we couldn't imagine. The American officers showed him production statistics. Total combined Merlin family production from both countries over 200,000 engines. "You actually underestimated our capacity in your report," the American said. Hartmann looked at the numbers and felt a familiar despair. "Yes, I see that now. I should have trusted the evidence." The interrogator asked one final question. "Why do you think the partnership between Britain and America was so effective?" Hartmann thought for a long moment before answering. Because it was built on trust. Britain trusted America with their best technology. America trusted Britain's engineering expertise. That trust created cooperation that multiplied both nations' strengths. Germany trusted no one, and so we fought alone. Trust won the war. The story of Franz Hartmann and the captured P-51 Mustang is a case study in how strategic partnerships can multiply industrial power. The decision to license the Merlin engine to Packard was controversial, but the British government understood that survival required American industrial help. They handed over complete blueprints, metallurgical specifications, and decades of knowledge. It was an act of strategic trust. Packard responded by not just copying the Merlin, but improving it for American mass production. Trust had been rewarded with excellence. Germany's failure to build similar partnerships doomed its war effort. The Axis alliance was hollow. Each nation fought alone, hoarding resources and protecting secrets. The Axis lost because it was never truly an alliance. Hartmann's report had been ignored in 1944, but history had proven him right. The Packard Merlin and the aircraft it powered had helped achieve the air superiority that made Germany's defeat inevitable. In the end, the Mustang's success wasn't just about horsepower or aerodynamics. It was about two democracies choosing to trust each other with their most valuable assets, combining their strengths and working together toward a common goal. That cooperation, more than any weapon or strategy, had won the